Hello and welcome back. Today we're going to begin our journey down Code Contracts Lane. The Code Contracts project is a project that's being built by the Microsoft Research and Development area. And this is a project that is intending to provide language agnostic way to express coding assumptions in your .NET applications. This framework allows for an application to take advantage of design by contract concepts. And what is great about the Code Contract is that as of Visual Studio 2010 .NET 4.0, it will be a full-fledged member of the .NET framework, and it's something that came out of the research labs. Now, if you don't want to wait until VS 10 and 4.0, you can actually go out and download it right now. It will actually work with VS 2008 and top of 3.5. And to do that, all you have to do is go out to the Research and Development website and download it. Now, when you've downloaded it, it's actually going to install into a directory on your hard drive. This directory is going to be in your C program files, and it's under a contracts folder. And underneath this contract folder is a couple different files or folders you should pay attention to. There's the public assemblies folder. This is where it drops in the single DLL you need to import, which is Microsoft.contracts. It also provides you various different samples to take a look at so you can look at the different ways to do things. And then last but not least, there's also a fairly decent document that will explain all the various different usages scenarios and ways to utilize the framework underneath the documentation folder. So go ahead and download this, give it a shot. Now, once you've downloaded it, you will need to add a reference to it, right here. Now, I've done this by making a copy of the DLL local within my solution. You can do that, or you can pull out the GAC. And then you'll also notice that in the Properties pane within Visual Studio, there's a new Contracts tab. This Contracts tab will give you all the various options that you can choose to turn on and off. This Contracts tab will give you all the different options you can choose to turn on and off during your usage of the contracts. We're going to turn static checking on. I want to check in the background and show squigglies. And then I'm going to tell it to perform runtime checking all the time. And if you don't want these, you can actually change it to various scenarios and various usages. These are what I like to choose as the default. So let's come over here. I've got a very simple little application that does a whole lot of nothing at this point. But what it's meant to show you is how to use preconditions and postconditions within our application. And that's what we're going to take a look at today. A precondition is a way to check for a value being in range prior to doing anything. That's to guard against bad data being pushed into a method. And a postcondition is to ensure that when you leave a method, that data is correct. So if you look at my clocking example right here, you see I have some old legacy code. I have two if checks that will actually perform basic contract checking for me. The first one will check to see if employee ID is greater than 0, and the clock date is not equal to today. It'll throw an exception. Well, this works and works well, except for it doesn't give me static analysis on it, which is something that Code Contracts provides me. But what if I don't want to change all my code because I got maybe dozens of places throughout the application that use this style of checking? Well, fortunately for you, the contract team has thought of this. In order to do this, all you have to do is import the System Diagnostics Contracts namespace. And come down here and use contract.endofContract block. This will tell the static analysis checker that everything above this is considered a contract, and you should be able to perform your static analysis checking on that. To see how this works, let's bounce over to our test harness here. And I'm going to copy in some code real quick to save some time. Now I've got this unit test here. And you'll see right away that the employee ID of 0 does violate my contract. So let's compile this and see what happens. So it did compile successfully, but if I give it a few extra seconds, you'll see that the static analysis checker sees that my contract is being violated right here, and will actually provide me a squiggly. Now when I run this, you'll see what actually happens at runtime as well. You'll see that it provides me this dialog here that will tell me that my precondition failed and that the employee ID needs to be greater than 0. Well, this is great, but what if I don't want this to happen, say, during a unit test run? Because maybe it's possible that contract fails during a unit test, but I surely don't want this dialog here. Well, fortunately for you, they've thought of that, and there's a way you can handle that as well. If I come back into my unit test, if I paste in this code right here, this will set up and say that, you know what? I want to set it up so that when the failed event is raised, I want to handle that locally. Make sure to call the setHandled method, otherwise it'll continue to bubble up. and I'm going to set a local variable. And what this will actually allow me to do is do this. And I can say that, assert that it is true. So if I run through this again, my test should pass this time, and I should receive no dialog. And sure enough, it did finish, it did pass, and this did trap and cause my dialog to not appear again. Now what's also nice about this is there are various different things you can look at within this. You can tell what condition failed, the message, the original exception, unwind the stack. So this does provide a few more pieces of data as well. Now what if you say you don't have legacy code? How do you do this without the concept of legacy code? Well, all you have to do then is, instead of using end of contract block, use the requires keyword. The requires keyword is a way to do a precondition. Now what's different here is this isn't taking a value in a range, it's actually going to take an expression. I want to ensure that employee ID is greater than 0, and to save a few fat fingers here, I also want to ensure that the date is equal to today. And if I bounce over to my code, set another breakpoint right here, run this, you'll see again that my condition was violated, which means I have the true value here. And so what this just shows you is that you can use legacy code and have contracts still enforce status checking, or you can have it also do the preferred mechanism, and it'll do the same thing. Now that's some of the powerful usages of contracts, but to me, I can get a lot of that without the stack analysis in the code I have today. But what I can't get is the post-condition checking. That's something we're going to take a look at real quick right now. Now with the post-condition checking, all I want to do is this. I want to do contract.ensures, and then we're going to do this. Daily report not equal to null. Let's compile this and see how this works. It failed, but doesn't it make sense that the contract goes right before the return statement? No, that's actually not the way it's supposed to work. The contract needs to go first. Well, if I put the contract first, I can't use the declared object that's going to be returning my data. So what do? Well, contracts doesn't really care the instance of the object that's being returned back. It actually cares about the value of the object that's being returned back. So what I can do is I can do contract.result, and result is a generic. And I can say of daily report not equal to null. And this will actually satisfy my contract. And if I come down here and just for sake of this demo, turn my return value to null and try to rebuild this, you'll see that it will build. However, the stack analysis checker should check here in a second, and it does. That is proven to be incorrect. You can tell by this line right here. Now if I run this, go ahead and say get daily report. And if I run this, I should also get a violation. And sure enough, I did. So what I was able to prove there is that the contract actually did enforce that the return value is not null. And if I return this back to the actual value here, rerun my test, you'll actually see that the message doesn't get handled, which means that the contract wasn't violated. And this is false, which tells me the contract wasn't violated. Well, that's pretty cool. In a matter of about 5-6 minutes worth of actual demo time, we've been able to take a look at how you can utilize the require syntax, which requires that an inbound value is within range, and the ensures concept, which says that, you know what, when you're going to return a value, make sure that it's within range as well. And we've also taken a real quick look at how we can handle contracts within our unit testing scenarios so that we don't get dialogues which could potentially hose up our build machines and just cause general annoyance. So next time we'll take a look at some of the other usages, such as the object invariant stuff, which is really, really cool and powerful, as well as how you can do things with abstract classes and interfaces, because their idea on how to validate that and put the contracts on abstract classes is a little bit different than what you might have expected. So I hope you learned something. Until next time.